guys, welcome back to my channel, Genes and Genes. So in last week's video I mentioned the genetic disorder Xeroderma Pigmentosum and got an overwhelming number of comments asking me what it was. So in today's video we're going to be talking about how the UV rays damage our DNA and also what our body is able to do to fix this damage. And then we'll also be talking about the people who aren't able to fix that damage, so the people who are diagnosed with Xeroderma Pigmentosum. So our skin contains melanin. What melanin does is it acts as a barrier that stops the UV rays from coming from the sun and penetrating through the epidermis into our skin. It causes the UV rays to scatter away from the epidermis so that the UV rays don't penetrate through the skin and into the cells. So when you go to the beach and you turn red or even get a burn, that is because of the UV rays, which are damaging your cells. UV rays enter the cells and into the nucleus and damage the DNA. What they do to the DNA is they cause pyrimidine dimers. A pyrimidine dimer is when the pyrimidines inside of your DNA, so that's cytosine and thymine, covalently bind to each other when they're next to each other on a DNA strand, rather than binding to their complementary nucleotide on the other DNA strand. And so what this does is that it clumps up the DNA, and so this little area is silenced. It stops that DNA region from being transcribed. This could be a very important gene which could cause serious problems inside of your cell. So imagine you're at Bondi Beach on a hot summer's day at noon. Every hour you get 20,000 pyrimidine dimers formed in every single cell in your body. So that is a lot of damage that your body has to repair. And thankfully we are able to repair it. So we have three molecules inside of the nucleus which are crucial for this process. They're called UVRA, UVRB, and UVRC. What happens is UVRA finds and binds to pyrimidine dimer. UVRB then replaces UVRA, and then UVRC comes along and binds to UVRB. UVRC is what cuts out this DNA fragment and will release it. After that, DNA polymerase will come and replace the missing strand and by adding nucleotides. And then lastly, there's ligase, which seals the new fragment to the DNA strand. Now you have a fully fixed nucleotide strand. So Xeroderma Pigmentosum is a rare genetic disorder where people aren't able to fix this DNA damage. So it's autosomal recessive, meaning that its locus is located on the autosomes, which are the non-sex chromosomes. It is also a recessive disorder, meaning that for the phenotype to be expressed, it needs to be in a homozygous recessive. So for example, if two parents, which are both carriers, they have a 25% chance that their child will express this phenotype. So the people who have this genetic disease will not only get skin cancers, but many other cancers as well, because they lack this mutation correcting mechanisms that most of us will have. So because this is a genetic disease, children will be affected by it at a very young age. This will cause them to have a limited childhood. They have a much greater risk of getting not only skin cancers, but other cancers throughout the body as well. They will also experience other side effects such as a cloudy cornea, thinning of the eyelids, and non-cancerous growth. Unfortunately, a third of the people with XP will also experience many neurological disorders such as hearing loss, loss of brain function, and also loss of balance. It's a very devastating disease, but it's also very rare, with only 1 in a million people having it in the States. So by learning about this, we can see how important it is to have DNA repair in our cells, because without it, we wouldn't even be able to expose our skins to the slightest bit of UV rays. So thanks so much for watching, guys. If you want to know more about Xeroderma Pigmentosum, I'd highly recommend you check out Andrea's channel, also known as Nightland's blog. So she is diagnosed with this disease and talks about her everyday life and what it's like having to deal with it. So I'd highly recommend you check her out. Make sure to also like, comment, and subscribe to get our weekly videos about genetics. Bye!
We chose the topic of the effect of UV rays on skin cells as we thought this would be relevant and useful knowledge, and also because we felt that it would be a topic that we could present in like a fun sort of manner. My role within the team was mostly just research and script writing, but we all contributed equally, I think. So our team was really easy and fun to work with, and everyone did their part and tried to compromise on finding like a good time to meet, even though we all had like conflicting schedules. And we decided on a topic really quickly, and which was really good. And the research was done really efficiently because we split up and like all did our parts. I think the hardest bit was probably managing our time. We procrastinated quite a bit between having our idea and actually doing the script, and it was hard to coordinate our schedules to meet up in person. Also, the medium that we picked to do our video meant that only one person could do the animation at one time, which was not as time efficient as I hoped.
My role in the genetics group assignment was mainly research. We worked well together as a group as we had effective communication and there were no arguments. I found finding times we could all meet up the most challenging part of the assignment, as we all had very busy timetables. We chose the effects of UV on DNA as it affects every person as we are exposed to UV rays every time we go outside.
So my role in the video was to actually film and edit the video, since I've had the most experience in that. Our team worked really well together though. We found a topic really easily and separated all our roles evenly. Although what was hard was finding a movie style. We weren't sure if we wanted to do maybe like a news report or something else, but in the end we decided to do a vlog type YouTube educational video. But overall the team worked really, really well, and we all cooperated really well together.
My role in the team was to assist with research and also write the script for the video. We did find it difficult to find a time to meet up, however we communicated really well and eventually found an empty space in our timetables so we could meet up together. We chose the topic because it's really relatable, and we also all find it interesting how our bodies correct the mutations caused by the sun, and also what would happen if we didn't have those systems in place.